Now we have output. I'm not going to write it all down, but you can just look at the estimate column. So I'm going to write estimates. So we have our estimate column. It kind of tells us the estimators for the regression situation we're in right now. So we have intercept x1, x2, x3. Negative 0.19, negative 0.37, and 0.036. Okay, have this, and we just plug it in now. So our y hat equals 4.069 minus 0.19 x1 plus minus 0.37 x2 plus 0.036 x3. Now this is our predicted equation. I forget what, this is also a real output that I had, but I forget what it was about. So you're going to have to forgive me for that. Yeah, so this is the regression equation. Pretty simple. Okay, now we have, that was A, now we have B. Let's see, so now we want our value at x1 equals 1, x2 equals 1, x3 equals 11. And we're given that the true value, that we found when we collected the data was 5. Now we want to find the residual. Now in order to find the residual, we have to plug it into a calculator. And remember, the equation for residual is observed minus expected, right? Give me 1 second. It's observed minus expected, so let's plug that into the calculator. Y I minus y hat equals, let's see, it's very interesting, minus 19 minus 0.37 plus 0.036 times 11. And then we do, what is it? Let's see, 5 minus this. And we're given that the true value is 1.098. So this is the residual. I just did this minus what I got from my equation. Okay, now the question asks, does this tell you anything about how good the model is? Just from this residual. And while you think that, okay, so a few things. We have no reference point. We have nothing. We know nothing about this residual. We don't know if this is big, small, bigger than expected. We have no idea. So we would need all the residuals, and we would actually need to like, a useful thing would be to plot the residuals and see if there's like a trend. And if there isn't a trend, if they're just random, kind of like this, around 0, then that's good. That means that's okay. But it does not tell us anything about how good this regression model is, just from that one residual. So don't be fooled. And so we have no idea how big or small that residual is. Okay, and now for part C, let's do it up here. We want to do a hypothesis test for beta equals 0, beta 3 equals 0. Beta 3 is not 0. Okay, now so we're given that the t-value for beta 3 is, or for x3, is 0.223. Okay, this is the t-value, so, and it gives you a p-value of 0.8239. Okay, extremely high p-value when compared to 0.05, so of course we fail to reject, find that it's 0. And if we do a confidence interval for beta 3, we're going to get, for beta 3, 3.6 plus or minus. Since it was based off 120 people, we use 1.96 for, as the central limit theorem kicks in for the same reason as before, times the standard error, 0.16399. And this interval equals -2.223 to 0.357. Okay, remember this is a negative to positive interval, so that matches this conclusion. Perfect. It includes 0, so 0 is a plausible value, so we can't reject and say beta 3 is not 0. Okay. Now remember, this all goes back to just remembering how to interpret these things, how to do a confidence interval and a hypothesis test. They're always going to give you enough information. Just remember that. So don't just relax, and remember the output is for you. It is made to make things easier on you. Okay?
The Teaching Center, UF's Learning Resource Center.